All right, so number 1 is g of x equals x to the 4th minus 9x squared minus 4x plus 12. So this is kind of like what the review is going to be today. There's not going to be it's not going to be separated necessarily by what kind of equation it is. It's going to have more general directions. And it's either going to be write the factored form or it's going to be find the zeros. I could do both. But that's what we've been doing for section 2.5 is we're going to write the factored form, find the zeros. Okay. So the first thing that you do, no matter what the directions are saying, when you're actually ready to go find this stuff, the first thing that you're going to do is graph it on your calculator. So the first thing we're going to do is we're going to pull out our calculator, and I just happen to have one, but it's to change some modes around. I was using this in a different class. Okay, so type in my calculator. I'm going to graph it. I'm going to make sure my window is a nice window like Zoom 6 to start. I might change the window around, but that's the first thing that we're always going to do for these kind. We've been learning different pieces, like we learned that P over Q thing, which is the possible rational roots. We learned the positive, negative, imaginary chart last time. But with those extra little things, those are just extra little things on what we're doing, which is the main thing here is finding the zeros and writing it in factored form. So I'm going to look left to right, and I'm going to see if there's any zeros that I can find. So from left to right, do you think there's any that are obvious? -2 perhaps. So I'll check it. I'm going to go second, trace. Since it does look kind of obvious, I'm going to go with value. And I'm going to type in -2 just so I can see if that is true. And yes, it is a 0. So -2 is a 0. So after we use our calculator, you're going to find a 0. If it's an integer, use synthetic division. Synthetic. If it's a fraction, you need long division. So we found x equals -2. So that's an integer. So I'm going to do -2, and I'm going to use my synthetic division. If you don't leave a space there, you will get it wrong. And I use my synthetic division, and I do have a remainder of 0, so that means that I did everything correct, that's a 0, and I did everything correct. The original question was a degree of 4. Now it's a degree of 3. How many times should we repeat this? Graph it on the calculator, find a 0, take it out. How many times do we need to repeat that? It's not really a set number, but how many times do we need to repeat it? Chris, do you know? Until we're left with a power of 2. Right now we have a power of 3, so we're going to repeat that process. So I'm going to go back to my calculator, and I'm going to find another 0. Right? -2 a second time, because we see that the graph bounces at -2, meaning there is a multiplicity that -2 happens more than once. So I'm going to do -2 a second time. And I just go off of the answer that I got when I did it the first time. That's not right. What did I do wrong? Oh, yep. Thank you. So, like, the third thing I would say would be repeat until we have a power of 2 left, or quadratic. So it really depends what you start with, how many times you're going to do it. But I promise that you will be able to find enough of them that you'll get to that quadratic every time. I'm not going to give you any where you couldn't do it. So now we have a quadratic. And our choices are, for step 4, our choices are factor, quadratic formula, or complete the square to solve for last 2 zeros. Okay. So I made a mistake. Gosh, I didn't even catch my mistake. You guys didn't either. I made a mistake before. Can't add. It's a problem. All right. So this one does factor. Quadratic formula works. Complete the square works. Nobody want me to go do it by complete the square? So faster. It's not faster than factoring though. I would do it by factoring. It's faster than quadratic formula for this one it is, but it's 3. Okay, so now we have found all of the zeros. We're going to list our zeros from least to greatest. Left to right. Now, imaginaries. I will put the imaginaries on the end because when we eventually type something in a canvas, I would really like them to all be in the same order so it grades it correctly the first time and I'll have to do a lot of extra work. So I like to do the imaginaries last. From least to greatest. So you know imaginaries are always plus minus. So the minus one would be first, then the plus one would be next. So least greatest. Okay. So that's how I would list the zeros. This one doesn't have any imaginary zeros. So we just have -2, then 1, then 3. Now you want to kind of just double check things. Like we had a power of 4. Why do I only have 3 zeros? We had a power of 4. The -2, there was a multiplicity of it, right? It was squared. So we need to think about things like that. So when we write our factored form, so factored form, actually, I'm going to move this f of x because I'm going to write something else. Factored form, we're going to list in same order as the zeros, except if zero is a 0. That's kind of confusing, but that's the one where you just put the x in front. What?
So I was just wondering, like, when you had x minus 2 squared, like, isn't it when you undo the square, it's supposed to be plus minus? Right.
Let me write down what you're saying because I need to visualize what you're saying. What were you saying?
Right. So when you have it factored, you have x minus 1, x minus 3, and then x minus 2 squared.
Oh, okay.
And then, like, when you got that last factor, x minus 2 squared, wouldn't that make it there be a plus 2 and a minus 2?
Let me write it down and then I'll talk about that. Okay. So when we do these factors, the -2 is going to come first. So it's going to be x plus 2 first, and then the x minus 1, and then the x minus 3. Now here's another spot where I only see 3 factors, but there should be 4. So that's where we have to remember, oh yeah, there's a multiplicity of 2 for that -2 factor. So there we want to remind ourselves, and we need to make sure there's a separate factor for each degree. In all of your factors, will be linear, meaning they will all have an x to the first power. They will not inside of the factor have a squared. Outside of the factor is fine because like this x plus 2 squared is just 2 separate x plus 2's. So the squared on the outside of the factor is fine. Those are linear factors. But none of the factors on the inside should still have a squared in them. So Chris, if I were solving this for 0, both of them are x plus 2's. So they would both equal the same number, -2. It's different when you'd have just x squared, like minus plus 4. And then you move, no, I was wrong. I was right the first time, I mean, minus 4. And then we get x squared equals 4. Then you square root. That's different than just setting it equal to 0. And both of these are the same. Okay. I mean, okay, so you could square root. Let me go back. You could square root with this, set it equal to 0 and square root. Like if you were finding the zeros. And as I square root, I'm going to have plus minus 0. So if I do x equals -2 plus 0 or -2 minus 0, I still get just -2. Okay, there is one more check that we need to do, and that's what we learned yesterday, or 2 days ago, sorry. 7, we need to check for a stretch or shrink. So if I multiply together my first terms, I get x, and then that's squared, and then x, which gives me x to the fourth. And then we go back and we look at the first term, which is x to the fourth. So those are the same. What we learned last time is if they are not the same, we need to make them the same by putting in a stretch or a shrink. You did not get to practice putting in that stretch or a shrink on this past assignment because you didn't have to do factored form. You could stop at 5 for this past assignment. Okay, so the thing that we were doing with section 2.5 besides all of this stuff was we were learning about those P over Q values, the possible rational solutions, and we were doing the positive, negative, imaginary chart. So these are like the extras that were in section 2.5 that will be a couple points here and there, but the majority of the meat of what we should be learning and show mastery of is the stuff that I just listed here. So when you did or are doing this assignment, that's what you're supposed to do for every single one, except for number 6, you couldn't. Okay. So all of those, you were typing them in, looking for zeros, pulling them out. You were just going to have some imaginary answers in some of these. Yes.
Are we going to have our calculators on the quiz?
Yes. Like you have to, right? Yeah. So there should be, it should be really hard to do bad on this. I mean, you got to really try to do bad on this. Like, basically, if you haven't done any of your assignments, you're not going to know what you're doing. But if you have your calculator and you get to look at it, you just have to know things like, what's it called? Synthetic division, or maybe long division if it's a fraction. I made sure that on the review, I gave you a little taste of everything. And I try to keep it short. It's like 8 pages long, but that's because I put like 1 question per page. So you could just make it as big as you wanted to. Okay. So it's not really like, I think it's 9 questions on 8 pages. I think that's what it is. Okay. So today we are working on our review, and then you can ask me any questions. It can be about section 2.5 day 1 if you're that far behind. You can be about section 2.1 if you're that far behind, but that won't be on the quiz. So please ask questions and thoughtfully work through this today. We will have a quiz next class, and then we will start moving on to section 2.6. Okay? Yeah. Next class. For before you take the quiz, the review is 2. Before you take the quiz, not after. Get it done before you take the quiz. Okay. Other questions while I'm still recording? Okay.